My research is about the speech intelligibility in noisy conditions. Environmental noise is becoming the larger problem. For instance, the announcements should be intelligible in a noisy condition, but from this background, the announcements should not be louder. So we need to improve speech intelligibility in a noise without increasing sound pressure level. Lombard speech is the speech produced in a noisy environment, and it is more intelligible than plain speech when mixed with SSN at the same SNR. But why? Lombard speech is acoustically different than plain speech. Especially spectated flattening in Lombard speech may contribute to speech intelligibility. In past researches, LPC filter was used to transplant spectated features, but LPC is an all-pore model, so LPC cannot express nasal sounds because nasal sounds can only be represented by a filter with zeros. So we compare spectated modifications made with LPC and our method into aspects, modification accuracy and speech intelligibility gain. And we implement spectated modification on phone scale to examine the differences between LPC and our method in nasal sounds. This is a modification scales. The first is utterance scale. Utterance scale is a modification for whole utterance, and phone scale is a modification for each phone. And frame scale is the modification for each frame. We used Butterworth filter for rough spectated modification. Butterworth only has a roll of plus minus 6 n decibel per octave with filter order n. We also used FRF for fine spectated modification. FRF has a roll of 6 alpha decibel per octave with fractional filter order alpha. We conducted objective evaluation. The modification accuracy is calculated as the absolute error, and the objective speech intelligibility gain is estimated by SIIB. These were the results of objective evaluation. It says that LPC is more accurate than FRF on the modification, but LPC has the larger SIIB value than FRF. And the correlations between mean SIIB gain and absolute error say that the positive correlation on the utterance scale, fractional roll of filter, and on the frame scale, both modifications. We also conducted subjective evaluation on the 6 conditions, plain, Lombard, and modified plain speech on utterance and phone scale. This is a procedure. Each utterance has 2 keywords, letter and digit, such as, in this case, set green at Z1 again have the keywords as Z and 1. So participants identify the keywords from the stimuli. This is an example of the stimuli. The first is plain speech.
Been read by P0 now. 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 Been read by P0 now.
And this is the information of the participant. This is a relative keyword correct gains over corresponding plain speech. This is very similar to the results estimated intelligibility by SIIB, but these results are slightly lower than SIIB results. And we analyze the subjective response for each utterance by BRMS. The result says that on the utterance scale, the keyword correct score decreases for both modifications compared to plain speech, and APC transplantation are superior to FRF ones on keyword correct gains. We also analyze the subjective response for modified utterances by BRMS. These results imply that consistently weak positive correlation between keyword correct score and absolute error on each method and scale. By focusing the effect of nasal sounds, no effect of nasal sounds on keyword correct was observed between LPC transplantation and FRF. Unlike our hypothesis, no difference in keyword correct scores with nasal sounds was observed on the phone scale. But a difference in keyword correct scores with nasal sounds was observed on the utterance scale, but no clear conclusions can be drawn from these results. Spectated modifications with FRF have smaller absolute errors than modifications with APC transplantation. Utterances modified by APC transplantation yielded larger speech intelligibility in noise than FRF on objective and subjective evaluation. It implies that spectated cannot capture the spectative features of Lombard speech that improve speech intelligibility in noise. And there are positive correlations between speech intelligibility and absolute error. From this result, we concluded as when presented in noise, the intelligibility gains of plain speech modified to have Lombard spectated may be smaller than previously reported. This research is extended version of our research presented at IEEE workshop on ASRU 2023. This is a reference. Thank you.